All right, so on Monday or Friday, we talked about two other triangle centers. We talked about the circumcenter and the incenter. Today we're going to cover the other two, which are the centroid and the orthocenter. All right, definition of a median goes in your notes. All right, so the median is the line segment that connects the vertex of the angle to the midpoint of the opposite side. So these two segments are going to be congruent. Want to make it clear that the median does not necessarily bisect the angle. Okay? It doesn't have to bisect the angle. For example, I could have an obtuse triangle like this, where the median would be someplace over here. It still isn't a very good picture. But just because these two are bisected doesn't mean that the angle is also bisected. Median and angle bisector are not the same thing. They can be, but they're not usual. All right. The centroid is the point of concurrency of the median. So that also goes in your notes. All right. So again, if these are each medians of the triangle, we have to understand that this segment is going from the angle vertex down to the midpoint of the opposite side, which means those two sides are congruent. Okay? Since a triangle has three medians, this guy is bisecting this side, and then this third guy is also bisecting this third side. So I've got a special relationship. I've got some congruent sides going on, some congruent pieces. All right. Just like with the circumcenter and the incenter, where we had special relationships of the line segment, interior line segments, the centroid has a special relationship also. So the relationship from the for the centroid side lengths or medians up for the centroid is the length of the segment from the vertex to the centroid is twice that of the centroid to the midpoint. Another thing I want to mention about the centroid is sometimes you're not going to see it written as this. This is the easiest way that I found to remember the relationship between the median or the median length, or the relationship between this portion, the longer segment, and the shorter segment. Sometimes, though, and more often than not, you're going to see this written as the median is this distance is 2/3 of the total distance. So if you think about it like this, 2x, that means I've divided this segment right here into 3 equal pieces. Okay, this is taking up 2 of the pieces, and this is taking up the 3rd piece. So sometimes you'll see that this segment right here is 2/3 of the total length, and that this tiny little segment would be the 1/3 of the length, which is basically the same thing as this said. This guy's taken up 2 out of the 3 pieces, and this guy's taken up the last one. So sometimes you'll see it written as a fraction. I think this is a little bit easier. All right, let's put it to use. If CM is equal to 8, so since this is the shorter distance, what would be the distance from H to C? If this is 2x and this is x, so if x is 8, what is 2x going to be? 16. So this line segment is going to be 16. Pardon me? So the question was, does that mean the whole thing is 24? And the answer is yes. 16 plus 8 is 24. All right, what if my whole length is 18? Okay, so if I'm going to cut 18 into 3 equal pieces, let's cut it in thirds. So my smallest line segment is going to be 6. What does that make this one? 12. It has to be twice that, right? Has to be twice that. What if my whole segment is 48?
The bottom one would be 6 and the top would be 8.
No, first I'm going to cut 48 in thirds, which is, what's 48 divided by 3? 16. So this guy is 16, and this guy would have to be 32. Okay? Make sense? Okay, and that holds true for each of these medians. For example, if this length right here was 12, 12 divided by 3 is what? 4. So this guy is 4, which means this guy has to be 8. Okay, everybody good on medians? Okay.
Yeah.
All right. Altitude in your notes. So the orthocenter is the point of concurrency of the altitudes. Okay, so before you start writing, I want to explain it could be inside on the triangle or outside. Just like the circumcenter could be inside, outside, or on the triangle. The orthocenter has similar properties in that way. Okay, so these are the altitudes, the perpendicular drops from the vertex of the angle down to the side of the triangle. Not a bisector. Okay, it's just making a perpendicular line. Doesn't necessarily, it could bisect, but that's a special case. Okay, it could bisect, but this one is not. Clearly, this is not congruent to that. Okay, so each of these is the perpendicular line to the opposite side. So when I have an acute triangle, which is this guy, the orthocenter is going to be on the inside of the triangle. When I have a right triangle, it's kind of like a special situation going on here because the perpendicular line from the angle, from this angle down to the base, is actually one of the sides of the triangle. Okay, and the same thing is going to be happen here. If I turn this guy like this, the orthocenter from this angle to this base is also that side of the triangle, because those are the perpendicular lines. Okay, and then this would be the perpendicular to this side. So the orthocenter, when I have a right triangle, is actually at the corner of the right angle. It's where the right angle is. So that would be the orthocenter. When I have an obtuse triangle with an angle greater than 90 degrees, the orthocenter ends up being outside of the triangle. So these two properties, the orthocenter and circumcenter, have both of these in common. Actually, the orthocenter has when in a right triangle, the orthocenter and the circumcenter are both on the triangle. For the orthocenter, it's the 90-degree angle. For the circumcenter, if you remember, it was on the hypotenuse of the opposite side. All right, so we're going to go ahead and move on to the worksheet that you picked up when you walked in the door. This is a review worksheet of all 4 of the centers that we have talked about so far. So the first 4 questions ask the angle bisectors of a triangle. What is their point of concurrency? Where do they meet? So you're going to probably need to go back and check in your notes like I have to. I don't remember all of these either. Go back in your notes and check which one goes in each blank. Take a couple minutes and see if you can figure it out. So angle bisectors, oops, that's not what I wanted. I wanted this guy. Angle bisectors of a triangle is in center. The medians of a triangle, Dylan, which center is that? So look in your notes. The medians, point of concurrency is the centroid. So the orthocenter is where the altitudes meet, and I'm not even calling anybody for that one because that's the last remaining vocab. All right, so make sure you get that on your paper. All right, 5 through 10, you should have in your notes. I want you to go through on your own and see if you can pull the answers out of each of those questions from your notes. All right, so answer 5 through 9 we have up there. Number 10, I definitely want to cover this as a class. So a circumcenter, we want to find out if the point of concurrency of a circumcenter is inside, outside, or on the triangle. So looking back in your notes, I think I had you write that down. Circumcenter, you either have 2 choices. It's always inside, or it can be inside, on, or out. All right? So looking at your notes from circumcenter, where does the circumcenter lie? So the circumcenter can be outside, also can be on the triangle. So when I have an acute triangle, the circumcenter is going to be where? Inside, outside, or on?
Outside.
An acute
Oh.
is inside. Obtuse, outside. right is going to be on the triangle. Okay, that's actually going to be the case also for the orthocenter. We learned that today. The orthocenter, when it's an acute triangle, is going to be inside. When it's an obtuse triangle, it's going to be outside or outside of the triangle. And when I have a right triangle, the orthocenter is actually the 90-degree angle vertex. We talked about that, so it's on the triangle. All right, the in-center and the centroid, always going to be inside the triangle. They're not going to get outside of the triangle, no way, shape, or form. So both of these are inside the triangle all the way across. Let's move on to the next page for section. All right, so this is what you're going to have to do to finish or to complete this stuff at home. Let me blow this up a little bit so we can see it a little better. All right, so it's saying that point G, this point right here, is the circumcenter. So you're going to have to go back in your notes and you're going to have to figure out what is or what are the properties of circumcenter. So if I go back in my notes, I think we already did this a little bit earlier. If I go back to my notes and I try to find out what a circumcenter is, I know that the distances from the circumcenter to each of the vertices are congruent. So, okay, I got that information in my head. Okay, it's going around in my head. So I'm going to use that information to answer the question. All right, so now that I know the distances from the circumcenter to each of the angles is congruent, I'm just going to go ahead and label that information because that's what I know right now. All right, so now I can answer the questions. AG, I'm trying to find the distance of AG, which is this guy right here. Well, I have to look for a distance of one of these other two. I can see this one is 25, so AG also has to be 25. All right, number 12 is BD, looking for BD, which is this guy right here, not 15. Okay, remember that these guys are the perpendicular bisectors, so that this and this are congruent, right? So then this would have to be 20. All right, CF. I'm looking for this guy. That was, no, right here, CF. The base, half of the base of the triangle.
24.
It's going to be 24. Good. CF is from here to here. If this is 24, then CF is 24. AB is going to be, where is AB? This guy, this whole line segment is AB.
That's going to be 40.
Good. If this one's 20, that one has to be 20, so the whole shot has to be 40. CE is, where is CE? Good, 15. Here's CE. That one's 15, so this one also has to be 15. AC is, good, 48. One's 24, so the other one is also 24, making a total of 48. Let's go ahead and mark the 24 on there. Skipping the angle. All right, last one. If BG is 2x minus 15, so BG is this guy right here. That guy's 2x minus 15. What does that have to be equal to if this and this and this are congruent? Has to be equal to 25, because this has to be congruent to that.
Yeah.
So then you can go ahead and solve. Adding 15 to both sides is going to give you 40, and x is going to be 20. All right, any questions? So for the remainder of the worksheet, you're going to look, it'll tell you what the center it is. You're going to have to familiarize yourself with the properties of that center, and then you'll be able to answer the question. All right, everybody good?